Okay, so here we've got x in terms of the parameter t and y in terms of the parameter t, but they're fractions, okay? And of course we've got to differentiate it. It becomes difficult when you have fractions. So you've got to see here what's the best approach. Now with this one, of course, because there's 1 on top is a constant, what I can do here is sort of package this up into a bracket and take the whole thing up. So it becomes 2t minus 1 to the power minus 1, okay? And then I've just got a bracket to a power, and I can differentiate that. I can do dx by dt, because remember what we learned earlier in the year, when you've got a bracket to the power, well, you differentiate that bracket essentially. So you bring that minus 1 down, put it in front, so put a minus there, you don't have to write the 1. You can if you want, put the 1 there. I'm just going to write minus 2t minus 1. You reduce that power by 1 then, so you get minus 2. And you times by the derivative in there, differentiate in there, you get 2. So that's the chain rule, okay, which you've used a lot earlier in the year. So there you go, there's our dx by dt. So let's tidy this up a bit. What I can do, because I've got a minus there, and the 2, well, I can write minus 2, and I can actually take that bracket all the way down, can't I? Because it's a negative power. So I can write it like that. Okay. And that's dx dt. Remember then I want dt dx, so I can flip that. So in that case then I'll still have a minus there. But on top then I'll have 2t minus 1 all squared, and on the bottom I'll have 2. Okay, so there's my dt by dx sorted. Now, it's a different story here, okay, because we've got a function in terms of t on top and bottom. So to differentiate that, you've got to think, well, we've got variables on top and bottom dividing, so I'm going to have to use the quotient rule here, okay, the quotient rule. So if you remember the quotient rule, u is the function on top, which is t squared, and v is the function on bottom, which is 2t minus 1. And then you need to differentiate, okay, so remember now, this approach, you differentiate the top one. Okay, so the u is the top one, v is the bottom one. So u is t squared, differentiated. So you write u dash here. So it's a quick way of writing du by dt. So just u dash, so differentiate that, you get 2t. And v dash, differentiate this, you get 2. So remember the quotient rule, okay, which we learnt. Okay, remember the quotient rule was dy dx is equal to v du dx minus u dv dx all over v squared. Now of course that's in terms of x, but the same principle will apply here in terms of t. Okay, so we want to basically do v du dx, so that times that, so 2t minus 1 times 2t. Remember then it's a minus u times dv dx or dv dt, so u times that, so t squared times 2 all over then v squared. So you've got to square this. There's your v, so you can square it, and you've got that. Okay, so it looks kind of messy, but that's what dy dt will equal to. Okay, so it's a case of trying to tidy this up to see if we can make it a little bit nicer. Now when I have a product, well, quotient rule rather, when I use the quotient rule and I've got a bracket on the bottom there, don't expand the bottom. Keep the bottom as 2t minus 1 all squared, but it's the top you want to sort of see if we can expand this and make it a bit nicer. So 2t times 2t is 4t squared. And then minus 1 times 2t is minus 2t. And then minus t squared times 2 is minus 2t squared. So you're left with 2t squared minus 2t on top. And keep the bracket as it is there. Okay, keep the bracket as it is. One more thing we could do on top is factorize out. You can see 2t squared minus 2t. Well, let's take out a factor of 2t. So in the bracket then will be t minus 1 all over 2t minus 1 all squared. Okay, so I've got an expression for dy dt. using the chain rule then. Okay, so I've got for the chain rule dy by dx is equal to dy on top by dt times then dx on bottom, so dt by dx. So I've got dy dt, which is 2t t minus 1 all over 2t minus 1 all squared, and dt dx was that result I had a few minutes ago, which is that there, minus 2t minus 1 all squared over 2. So then what you'll notice nicely is you've got 2t minus 1 all squared on bottom will cancel with the 2t minus 1 squared on top, and the 2 on the bottom here will cancel with that 2 there. Okay, so I'm left with then that minus, we can go at the front, t bracket t minus 1